Vietnam, a developing country, rich with traditions and great aspirations to modernize. One of the government's biggest ambitions, to grow their busiest shipping hub into a global superport by 2050. It's critical to their economic future. To do that, they're using a technology that's revolutionizing the way we design, build, and run systems around the globe. Geospatial digital twins, GIS-enabled 3D models of the physical world.
The technology has been around for many years. What's exciting now is that the technology is available and the workflows are accessible to everybody. It no longer takes 6 months or 12 months to create these simulations to solve these real-world problems.
Now the 3D and real-time capabilities of GIS have evolved to where geospatial digital twins are easier to create and can address a growing range of business needs. To reach their goal, the Vietnamese government joined forces with PortCoast, a leading engineering firm in the country.
What excites me with the work that PortCoast is doing is that they have the recipe down at a scale I've never seen before. With Esri GIS technology, they can manage the entire life cycle of creating, managing and maintaining a digital twin because they can integrate all these different data systems together using GIS.
There's multiple elements that we can bring into the digital twins, combining ArcGIS as a platform that can be expandable from small scale to large scale.
The process starts by mapping every surface of the existing port complex to create the core 3D visualization.
To capture the existing site, we send out a fleet of drones equipped with photogrammetric sensor and LiDAR sensor. On ground, we use terrestrial laser scanners. Then we use unmanned vessels to survey the seabed.
All that raw visual data, terabytes of it, get processed through ArcGIS Reality, integrated with Autodesk Construction Cloud, then finalized in ArcGIS Online, creating a single, authoritative 3D model that anyone in the organization can access. And because it's built on GIS, additional data layers like weather forecasts and marine ecosystems can be added.
So it's not just this static map anymore. It's really evolved now into something a lot more dynamic or living that's using all the different layers of data that are required to manage a modern port, using GIS as this hub to connect all this data together.
The integration of all this diverse data results in a map that mimics real-world activities. The digital twin now enables real-time monitoring of port operations. As the site develops, updates to the model can be made more easily than ever. Structural changes can be revised on the fly by field workers, while sensors feed live data to the digital twin.
Using ArcGIS solutions, we can tell when the ship's coming, what kind of cargo they are bringing, what equipment is ready to use, and the location of the workers and the related equipment.
The digital twin helps us to reduce the emission and to make the business more efficient in the way we use the resources.
The digital twin can also help them learn from accidents.
An event occurred where a barge actually ran into the pier and caused damage to the structures under the ground. But because they had mapped everything and they had everything digital, they were able to run this scenario-based modeling to understand why it happened and prevent it from happening again in the future.
The digital twin is also being used to design what comes next. When there are undeveloped sites, building a digital twin means designing and building new structures on raw land. This makes integrating landscape data with structural data vital for sustainability initiatives. Take, for instance, a processing plant planned for the superport expansion.
After collecting the data of the site, we use Autodesk solution to design 3D models of the plant and place them on the GIS platform integrated with the reality capture.
The models help teams explore layout options and build in documentation data, which will allow for more accurate and efficient construction. Once building starts, the digital twin can be used to track progress in near real time. They can monitor how materials are used, equipment status, and more.
The client will see their project change every day, so they can immediately take action to solve the problem or to make decisions.
And the digital twin lets them plan even further ahead. Even now, the digital twin can be used to plan for 2050, helping them to understand how changing conditions might impact where and what they build.
Using GIS as the feeder into game engine technology, they're creating what-if scenarios. It's quite an agile ability to do scenario planning.
The digital twin can answer questions like, if traffic increases by 25%, where might dredging be needed? Or how will sea level rise affect the terrain? And as AI is implemented, it will take digital twins to the next level.
With ArcGIS GeoAI, we can now analyze the site faster than ever.
We're moving digital twins from just being static to being predictive. And now with AI, we're going to start seeing how we can move digital twins to being almost completely autonomous.
What seemed daunting a few years ago is now a fast, streamlined, and scalable solution.
We are developing many digital twins in multiple countries for other complex infrastructures like plants, heritage buildings, inland waterways, and railway systems.
In almost every industry, this technology is going to transform how organizations are working. And they no longer have to use 2D maps to solve 3D problems because the technology is here today. They're proving these capabilities, and the ROI and the value you can create is readily available. So this really is an example of how GIS capabilities are creating these living digital twins.